Hi, everybody. I'm Mark Miller, and I'm the CEO of Biosynthetic Technologies. I want to thank everybody for taking time out of their busy schedule to come and hear our presentation today. As you probably know, BT is a US-based innovative company, and we are dedicated to developing bio-based alternatives to petroleums. Our vision is to create and deliver innovative solutions for a sustainable future, and our mission is to become the premier synthetic-based fluid supplier across a variety of specialty markets. Estolides are the answer for sustainable lubricant base stocks. From an environmental perspective, they are biodegradable, they have low ecotoxicity, and a low propensity for bioaccumulation. And from a performance perspective, we have addressed the traditional issues of biodegradable base fluids, including hydrolytic stability, oxidative stability, extreme pressure, compatibility with elastomers, solvency, and demulsibility. From a sustainability perspective, when I first got into sustainable fluids industry, back in the days that I like to say green was still a color, the key issues in sustainability was it renewable? Did it come from a bio-based product? And was it safe for the environment? Was it high biodegradability, low toxicity, and low bioaccumulation? As the industry moved forward, performance became important, where the performance had to be equal to or better than the petroleum analogs. And then as we moved again, what is the total cost of ownership? What are the basic price points for these type of materials? Nowadays, the bar for sustainability has been raised so high that you're looking at your life cycle assessment, your total carbon footprint, what is the social and economic impact to your relevant stakeholders. So we believe in circular sustainability. We look at it in terms of sustainable agriculture, sustainable economically, and providing carbon negative solutions. And when we did our life cycle assessment, we looked at our raw material inputs and outputs, we looked at our manufacturing impact, our manufacturing processes, and our material handlings. And what we found was we needed to be sustainable both from an environmental perspective and from a social perspective. So we're not competing with food, we're creating jobs and social welfare. The crops can be harvested on multiple occasions. We are also geographically centered. Our manufacturing is geographically centered, so you're not moving a lot of material through large geographic areas, minimizing the CO2 usage. Our primary manufacturing facility is 100% renewable energy, with a local wind farm providing electricity, with the boilers using spent castor cake from oil crushing. And as a result, we are carbon negative, and for each ton of a biosynthetic estolide that we make, we're absorbing 9 tons of CO2. We've reached the gold standard of environmental performance, targeting the benchmarks as standard as derived by the industry. So in terms of biodegradability as measured by the OECD 301B, sort of our lower viscosity materials have almost 90% biodegradable, and even our very high viscosity BT75, which is an ISO 680, is greater than 76% biodegradable. The benchmark for most eco labels and most environmental performance perspectives is 60%. In terms of the bio-based content, also very, very high. Our lowest material, the BT4, which is an ISO 22, is roughly 70% bio-based, and our highest viscosity material is almost 94% bio-based. We are now working on and are in the process of commercializing a much higher level of bio content, and we think we'll be approaching about 100% bio content. Looking at the bioaccumulation, all of our materials have very low potential for bioaccumulation as measured by the OECD 107. And looking across the slate of the OECD 200 series for ecotoxicity, our products are greater than 1,000 parts per million across the board through a variety of species, where the relevant industry standard and benchmark is 100 parts per million or milligrams per liter. So we're looking at today the base oils in lubricant applications. The estolide molecule is it's a beautiful thing to me, but I may not be 100% objective. What I like about it is it's highly customizable. You can derive it from a variety of fatty acid feedstocks. You can utilize 12-HSA from castor. You can use oleic acid from soy or palm. We can control the oligomerization, which will change the viscosity and change the alpha and beta capping groups to change the oxidative stability, to change the hydrolytic stability, to change the cold temperature properties. So it's a very unique molecule that we could make work in a variety of different applications. It's easy to formulate with. They behave very similar to petroleum analogs. We offer currently 3 viscosity ranges: a low viscosity, a medium viscosity, and a high viscosity material. They are completely miscible so that you can get in between viscosities. They have very high viscosity indexes or indices. Their pour points are average, but we have a path to much lower pour point measurements down to -33. They offer very good NOAC volatility and obviously would be resistant to shear. One of the things that makes them very easy to formulate with is a very low aniline point. If you look on the right side of the bar chart, you'll see that the BT75, the BT4, and the BT22 are amongst the lowest. That means they are readily miscible with a variety of base oils and additives, and also give good solvency and cleanliness. I mentioned earlier, one of the well-known weaknesses of biofluids is the hydrolytic stability. So we developed what we call our hydrolytic stability torture test. And basically that's taking a sample, adding in 1% water, maintaining 180 degrees F, and we measure the acid buildup over time. And you'll see that traditional esters break down and form acids very, very readily, where the estolides barely moved off the zero line, showing excellent protection against hydrolytic instability or breakdown in the water. Also, we talk about best-in-class oxidative stability. So when we compare this across a wide range of synthetic base oils, and we've also included a group 3 base stock, you'll see that utilizing a 1% AO treat across all the materials, our estolides are best in class, offering oxidative stability equivalent to the group 3 base stocks and the low viscosity PAOs. So what we've been doing, especially during this pandemic, was we've been developing prototype formulations of finished products. It's not our intention to offer finished products into the marketplace, but what we want to do is help our customers and prospects with some of the formulations and prove the performance of the estolides as a base oil, as a co-blended base oil, and even as an additive. So let's talk about gear oils first. We made a 100% estolide-based gear oil utilizing the base fluid, the additive manufacturer's recommended treat rate at 5%. You can see we got the highest across a board of a variety of commercially available gear oils in terms of the 4-ball weld load. Using a reduced treat at 3%, we were able to reach top tier performance from some of the best in class. And the estolide, even of itself, is and also ran in terms of a weld load as compared to conventional commercially available gear oils. So what we did next was we made a 100% estolide-based gear oil targeted at a 220 grade. We wanted it to be eco-label capable, and what we were able to do is put this together. It offered excellent performance, has an extremely high viscosity index of 178, has an excellent 4-ball weld, and sadly, my face, I think, is blocking the saltwater testing, but we had an outstanding pass on that. Let's see if I can get rid of the ugly mug. Nope, not going to be able to do that. Sorry. Then what we do, we were encouraged with those results. So we then went out to do a full test of the DIN 51517-3 and the China GB specification. And you can see that our gear oil passed in all the categories. 2 commercially available synthetic bio-based or environmentally friendly eco-label gear oils failed. But what makes it interesting to me is it had excellent oxidative stability. It passed the foam test with flying colors and offered excellent demulsibility, which are more of the unknown or known weaknesses of bio-based fluids. We wanted to develop a lithium complex grease to show its effectiveness in grease applications. We used sort of an off-the-shelf formulation. What we found unique here was that we were able to cook the estolide at 220 degrees C, homogenize it at 6,000 psi with no breakdown or no deterioration of the base oil. We then tested it against a variety of traditional specifications. We bumped that up against some of the GCLB specs, and we came up with what is a very nice looking grease. Moving further into the hydraulic fluids, one of the things we wanted to demonstrate, as we all know, PAO is sometimes difficult to blend with. We wanted to demonstrate the ability to blend or co-blend with PAO and the BT22, and we show here that we were able to make a very nice hydraulic fluid using an off-the-shelf ashless additive system. You can see it has an excellent viscosity index of 180, greater than 180. The low viscosity PAO improved the pour point. You can see a very strong oxidative stability at almost 800 minutes. And if you look at the inductive break, it's over 800 minutes. And in terms of hydrolytic stability, it passed with clean results. We then wanted to take a look at a vessel general permit type material. So we utilized a Group 3 base stock and our BT22 with an environmentally friendly additive system. We wanted to see what its environmental performances look like. And you can see in the OECD 301B biodegradability test, we passed with greater than 75% biodegradability. We had no acute toxicity across 3 major species in the 200 series. You'll also see that it has excellent viscosity index of greater than 162. What's really interesting to me is its very high level of demulsibility with a 40-40-0 in 15 minutes, and very good copper corrosion, and very good rust protection both in fresh and salt water. Showed excellent performance in terms of oxidative and hydrolytic stability yet again. This time we were shooting for an eco performance level, utilizing again a estolide Group 3 base oil. Again, testing for the environmental fate, showing very high levels of biodegradability, very low levels of toxicity. We were able to maintain the pour point, showing excellent rust, both with fresh and salt water, excellent demulsibility, virtually no foam. This time we went to Aegir Marine, a leading stern tube seal manufacturer, ran our product against their specification, or they ran our product against their specification, and we came through passing on all levels, showing excellent compatibility for vessel general permit type applications. Encouraged by those results, we wanted to do further testing on the ISO 68 using the same eco-label capable additive system. You can see again, it's offering excellent viscosity index, kind of average pour point, but what really looks good again is the copper corrosion with a 1A, the demulsibility with a 40-40-0 in 5 minutes, the foam breaking clean relatively quickly. We also ran it in the hydrolytic stability testing in both the copper weight appearance and tan came in clean and offering superior oxidative stability with 1100 minutes at the end of test and almost over 1200 minutes for the inductive end. We've entered into the metalworking market. We are now offering a line of metalworking additives. We'll refer to them as the BioSia line. We have BioSia 1, 2, and 3. They have a variety of different applications in terms of performance for general machining, cutting and grinding, and forming. So we're very encouraged by some of the early results we've been seeing in them. In terms of some twist compression testing, seeing that the BioSia 3 HP, the highly polar version, shows a 16% increase in the performance against any of the other additive products. So I think that's a good start to some of our metalworking additives. So I appreciate your time and hope to be available for any questions. Follow us on social media. You can follow us on LinkedIn. You can follow us on Twitter. You can visit our website and follow our blog. Thanks again for all of your time and attention. And I look forward next year to getting together and spending some time person to person, face to face, seeing my old friends and meeting new ones. Thanks again. Bye now.